I'm excited to announce our new DevNation Master Course live series. We're going to be live training, often in your local time zone and in many cases in your local language. We're going to be offering you things like Kubernetes, Knative, Tekton, Istio, and of course the Kubernetes native Java known as Quarkus. We're going to be showing you things like microservices and how you deploy all those things into a Kubernetes cluster, and we're going to be having a lot of fun together. Please join our live sessions and let's learn together.
Hello, and welcome to this very first series of Kubernetes Master Course. This is a beginner's one to start with today, and we have a series of things lined up in upcoming weeks. It's really a great pleasure seeing all, meeting you all virtually. I just take this moment to hope that everyone is safe and healthy wherever you are, and hope we get back to see you live. So this is going to be a 90-minute session. So probably the first 30 minutes, I will try to see like everything is covered on the basics and theoretical side of the Kubernetes stuff. And then we go, the rest of the time we'll spend around doing some demos, basically working with few objects and other stuff on Kubernetes on whatever we learned. So that's going to be the thing. So it's going to be a 90-minute session. Probably it's going to be packed throughout. Maybe we might jump plus or minus 5 or 10 minutes extra, but I'll try to keep it within 90 minutes. So whenever doing the sessions, if you have any questions, please do drop it on the chat. I'll be monitoring the chat during the session. I can take the questions, all the technical questions out. I have my other friends, Red Hat friends on the chat as well. They can answer any generic Red Hat related questions about the session, upcoming sessions, and all other stuff. Right. With that, probably I'll just take a quick moment, maybe a 5 to 10 seconds pause to see everybody's hear me well, and they also see me well as well before I go further. I hope I suppose, so you can just ping me on the chat to see like if you all hear me well and see me well before I start getting into the slides and talk about the core context of the session. So I know this is a YouTube live, so naturally there is going to be a slight delay between the time I talk and time it reaches you. So I will take this moment to have quite a bit of pause before everything is good. And thanks, Pratik. I think I see this audio is good and video is fine. So that should be the case for people who are on the YouTube link live. And that really gets me excited to move further. So let me get started. So this is about what I do. My name is Kamesh. I work as director for developer experience for Red Hat, basically doing evangelism on OpenShift, Kubernetes, Java, serverless, Knative, or whatever you name it right now, whatever you see on my screen. I've been with the IT industry totally. I think this is my 20th year. I'm happy to share that I have crossed 2 decades, completely a Java programmer from day one to day end. So all the examples I'll be talking on this session will be on Java. But don't worry, like it's the same applies to whatever programming language you are in. I put down my email ID and I also put on the QR code of my Twitter handle. I can grab them and follow me on Twitter and DM me if you have any questions on this session or anything related to Knative, serverless, Kubernetes, Java, OpenShift. I'll be happy to answer your questions. I've also put down all other social handles of mine. You can ping me there. And I'm also super happy to share with you that I got my book released a couple of months back. I put down the link of the book right below on the screen. If you see on the screen, there's a Knative cookbook, which was launched a couple of months back. I can click on the link there to get it downloaded. It's a free ebook, which you can get started with Knative and serverless. Obviously, we'll be having a session on Knative serverless later down the lane in upcoming weeks. And please watch out for that to join that session as well. With that, so let's see what we have for today. So today is a beginner's course. Obviously you'll also be got an email if you enroll for an elementary course as well. And obviously we'll get all these slides as well as part of your thank you email from us. So you should be seeing those slides as well. The slides are public and shareable with you as well, so they'll be shared. And this is the beginner master course. So what you're going to see today is why Kubernetes, what Kubernetes, and installation. I'm not going to cover about complete about installation. I'm going to use a hosted OpenShift installation, which is nothing but enterprise Kubernetes. And then also see like we have kubectl, pod, replica, set, and deployment. These are the very elementary objects that we are going to play with today, which is going to be part of the beginner session. And then you'll see how to steal logs and access a service from outside. Before I go further, I'll just take a quick check on to see if there is any questions on the chat. um, that's good. Like we are all good with this. Excellent. So uh, yes, I think Ratuja, I think you should be getting the slides from us. I think that will be part of the well. I mean, thank you email. You should be getting us officially from us. So don't worry on that. The slides will be there. And also, like I'll also like to share, keep sharing the links of these. I mean, the tutorials or other stuff which as we go on speaking about this, so that you can access them live and then follow the instructions as well. All right. So with that, let's see why we need this. This is a very basic thing I want to get started with. If you are, I think I know a few people might have already experienced with Kubernetes, and few people might be new to this. I'll consider the people who are pretty new to this and who are at the elementary or beginner stage to understand why we need Kubernetes. All right. So just take an example, right? Just forget Kubernetes and OpenShift or whatever for a moment. Let's go back to our traditional way of doing application development, right? So when you start to do application development, what we basically do, when I said like I've been here for more than 20 years right now, then I started my very first Java project, right? My Java project was basically like I have to build a WAR, EAR, and other stuff and deploy it into an application server, and that goes through a process. And there'll be somebody sitting at the ops guys who will be deploying that in another application server, and then that goes into production. So that was the usual style we followed when I started the application. Been there for quite long until Kubernetes was introduced, right? But if you consider thing right now, the industry, the application server industry, or the application software industry, or anybody who's using software applications being used anywhere. So what we basically do right now is that there is going to be a deployment every week or every day or every hour, right? So that's how the production deployment goes. If you see the usual example I take is in your Amazon shopping app. Like if you see that the changes comes to you even the morning and evening, even the afternoon, right? You keep things changing for you so fast, right? And those people do a lots and lots of production deployment in a day, like hundreds of production deployment a day. That's the speed at which we are going today, because everybody wants faster returns on the thing that they invest on this. The business needs the response to be faster, quicker feedback from the user so that they can introduce new features, new stuff, etc., etc. And I don't deny that we are not totally done away with the monolithic. Still the monolithic matters, but the way of why people are adopting right now is more onto the microservices way. That what you see on the right side of the screen every week, every day, and every hour. If you want to do at this pace, then you have to adopt to a microservice architecture, because that makes you application deployed much quicker and much faster. Okay. um, that goes with that. So what happens is that so let's take a very simple challenge, right? What was wrong with our traditional way of deploying into application server? So let's see, and then it's just going to drive you to the context why Kubernetes becomes so important, right? So in this case, like let's say I'm again taking Java example. As I said, I was a Java developer, so I'm just going to take a Java example right now. So what I'm going to do is like I'm just going to, let's imagine a case. I'm just going to deploy a very simple customer app, right? So what I usually do is like I build the application, write the Java application, and then build the application app and make it a EAR, run some test on my local application, local machine, and then give it to my ops guy with a set of instructions, go and deploy this. But usually you land up something like this, right? So because most of the case, I'm considering the majority of people who are right now working on these kind of industry, like any other big SIs we are working with. So we usually do is like we work on a Windows desktop mostly, most of the cases, and very less, or it's going to be a Mac or it's going to be Linux in very small amount of cases, right? Unless and until it's going to be a dev or app or production server. So what we do here is like we develop this application. Consider my app. My app is going to be developed on Windows desktop. I'm going to use JDK 8 and run on Wi-Fi. That's going to be my Java application server using a MySQL database. I do all the tests. Everything works perfect. My test cases pass. And then I go and throw this out to my production, ops guy, and then the ops guy is going to deploy this in production environment, which is going to be totally different, right? If you imagine on the box on the right side, it's going to be on Red Hat Enterprise Linux, JRE 7, WebSphere 8, and Oracle 9. Boom, you're gone, right? A lot of things will fail, a lot of things will not work as expected. There might be issues, there might be bugs, right? So this is what has been the case, like when we are doing those 4 months, right? If you see the 4 months of development life cycle, if you've seen earlier, most of the time would have spent fixing these things up, right? How do I smoothly move things into production, and how do I implicitly test my application that is ready for production, so that I identify the issues at the earliest stage. That's going to be crucial piece of thing. That's where your Docker kind of containers comes into picture, right? Or Docker or any kind of containers that you build. I just call this as Linux containers in generic. And then we use something like a Docker file where I say, okay, I'm going to use Wildfly here. I'm going to add my configuration. I'm going to add my app servers, put my dependencies on, put my war on. That's going to be a Docker file structure as you see on this. And that's going to be little slow on speed. Yeah, sure. Deepinder, I think I try to be slow. I honor you, I think. So with this Docker file, what we basically do is like we take the Docker file, put them as guest OS, whatever OS. For example, let's consider it could be Red Hat Linux, and then I put an app server on top of that. I put some custom configuration again, and then I add some dependencies as well, and then I make the var, put the var also in. Now what I do is like I run the test cases against this Docker container, right? It's not going to be on your machine. It's going to be a Linux container as such, and then that's going to be the test where it's going to be run. Once my test is true, what I'm going to do is like I'm just going to take this one and then deploy them onto another container registry, right? And this Docker container again in production. Now, if you see the instruction that is given to your ops guys is going to be that run this container that's going to run my application. Finished. And he's not going to do anything. He's just going to run a couple of commands like docker run or whatever it is, and that's going to solve this issue because you don't need to worry about that. The environment is different, your OS is different, your Java is different, and all these stuff, right? It's not going to be there. And for that matter, as I said earlier, this is going to be the case with any programming language, not necessarily Java. I'm taking a Java example because it's easy for me to explain, but that's going to be the case with any application programming language you're going to use. Now we have solved a big issue like how do I run the same thing what I have on my machine is going to be the same thing what's going to be run on a production. We are pretty much confident on that, and the test we run implicitly we test for all issues and make sure that my application is robust. I cannot make my application completely out of issues, but still there will be issues. But we are make sure that whatever the issues that were arising earlier with the earlier style of deployment, like on all the different things without containers, without Linux containers, was totally different from what we do right now. All right. I take a quick pause here before I go further to see if there is any questions. You can keep popping my questions. I'm sorry about that. I am a little bit fast speaker, and I'm trying to become more slower. I'm on the process of doing it. So in case if you feel any I'm seeing you me faster, as Deependra was said, just stop me there on the chat saying you're going fast. I'll try to slow down again. I'll try to be cautiously slower. And sorry about that. It's more instinct thing which comes when I talk about technology, right? Great. So, but what is the problem? So, still with this container kind of things, what we did right now, we still not away with any kind of problems, right? What are the problems we have? So I'm going to talk about each of these problems, and we'll see how each of these problems are going to be tackled by our Kubernetes and OpenShift platforms. And I'll keep highlighting them when I go to those respective slides. But just take a moment to see like what all the problems we face right now, right? The very first thing, okay, I'm good with running as containers. Okay, so Docker run, I run some command, and then and then I run the container. The container is started. But if we see for a second and imagine for a second, so what happens if we want to run two services on the same VM, right? Let's run a VM. Assume that we run a container on a VM. Now I'm going to start a container, say Docker run or Podman run, and then the container is going to start running, and then it should be listening on 8080 port, for example. And then I'm going to get one more service that's also going to listen on 8080. Okay. Now there's going to be two containers which are going to be run on the same VM. And now the problem is right now what basically happens right now is that it's going to have a port conflict because that's going to run on both on 8080. So now what should do? Now that we land up with the very first problem, like how do I actually avoid port conflicts? That's fine. The second one is how do I scale them, right? So right now, for example, I just run with the application is running with a normal request load, and all of a sudden I suddenly see a big request and spike. Mean to say like people come out and say, okay, I have a Christmas season or I have a festival season is coming up, and people say, okay, my application is going to take a load. Now I have to scale them right now horizontally or vertically in whatever way depending upon your compute resources we have, and that should be done automatically again. Okay. And third, how do I manage them on multiple hosts? It's kind of more like a distribution of an application, as well as, for example, let's imagine a case I have an application which is dependent upon a database. Let's take a MySQL or PostgreSQL example. And due to performance reasons, what I want to do is like I want to put this application on the same node where the database is also running, just to so that I can do a local host call so that it doesn't go over the network and save a lot of resources for me, and the application is also faster to respond. If you imagine that case, now what happens is that in that case also, like I need to have something, I call something right now, and I'll say the right word in a second, and something which kind of makes sure that I can go deploy this application on a node which is going to have something called as a database in it, like a PostgreSQL database or a Mongo or a MySQL. And again, this should automatically happen, right? So I don't want to say, still we do it this way today. Also, we write somebody running a script. They'll go manually run a script and go and find out, okay, this application has this particular node as DB, so I'm going to go there. But I don't want that to happen. I want this to happen automatically. And in case if I don't find any node like that, I'm just going to fail. I'm not going to even do the deployment. Okay, make sure that proactively fail this thing. And now this is what I think with these 3 points, I'm trying to introduce a term called as application orchestrator. Now, what I'm talking right now is kind of an orchestrator which is going to do manage your applications. That's exactly like scaling, avoiding port conflicts, managing them at multiple hosts. So this application orchestrator is going to take care, right? We talk about infrastructure orchestrator. We are talking about other stuff earlier. Probably you would have known all these stuff with the cloud technology in place. But now I'm introducing something called as an application orchestrator. So now what happens with application orchestra? We are done with these 3 things. The another fourth problem is that what happens if a host is in trouble? This is everyday problem in every production application that we run today. All right. So everybody would have faced this. What happens when I deploy my application and then I find that the node, basically the node as in compute, does not have CPU, does not have memory, does not have disk storage. Now, imagine earlier case without an application orchestrator not doing this, what happened? Your application gets deployed onto a node, an application starts up, and then what basically happens right now, the application will not go start running because I don't have enough resources for me to run. But that has to be taken care by your orchestrator itself when it deploys application. So many of the orchestrators will not do this. All right, that's be something we should actually go and do this. Right. I see a question right now. So does the container images includes all packages required? Example, guest OS, Java. Absolutely, that's right, Rohit. I think these are called as base images. So if you're going to come for the elementary session of this particular master course, we'll talk about base images. How do we build a basic application using base images? So it should be there always. And it's going to be managed application or container. So that's going to be, so I could call as application orchestrator, but end of the day, your application is going to be a container, Anand. So that's the reason like I call generically called as application orchestrator, because it's going to take care of other things as well. You'll see when you see the demos, and we'll see further up the slides, you will see it's not only is going to deploy the application, it's also taking care of making sure there's no port conflicts, there is no scaling, etc. Right? It's just going to run the containers, then you can say as a container orchestrator, but it's not doing that. It's doing a little bit more than that. That's the reason why I call it an application orchestrator. Right. So with that, so what I was also trying to say that is that what happens if a host is in trouble? We saw that host trouble, disk pressure, CPU pressure, memory pressure, that should also be taken care. And the third important thing is like how to keep them running. So this again another crucial thing when you get things to production, right? So what happens? Imagine a case. I usually take this example like if you heard of Zookeeper in the Java world. So the Zookeeper is kind of a thing which maintains your configuration, syncs up your node, etc., etc. So don't worry about what's that, but just imagine that this particular application needs to have 5 instances running always. Okay, just imagine a case. With that case, what happens is that let's see if one of the nodes goes down, then one of the instances goes down. Probably what happens is that the data will not be synced properly, and there will be a data loss until we get back to the 5. But what happens in a typical scenario? I'm talking all about these things without Kubernetes in place, Kubernetes or OpenShift in place. Is that when I'm kind of having a situation like this, so your alerting system will come up and say, okay, I have to have 5 nodes running. So 5 nodes is not running, so fourth node is running. So I have to go and send an email. That email has to be checked by your necessity SRE or your ops guys or anybody who's taking care of this environment. And then he has to go back and run the scripts to get them up and running. By the time all these things happen, you would have lost a certain amount of probably a considerable amount of data, quantity of data has been lost with this during this cycle, right? But how nice it will be like when somebody's keep tracking of these things, and then okay, once goes down, I know my desired count is 5, but my actual is 4, so I have to bring my actual to 5 again so that my desired and current are same. All right, so that's what again an application orchestrator should do, so that like, and always make sure that my desired and actual current running replicas, I'm introducing a term called as replicas here. You would have known about that. It's just a mimic of the same thing. So I'm going to get replicas is going to be same at any given point of time, and that has to be controlled and monitored by a robotic thing, which is going to be an application orchestrator again. All right, and how do I update them? This is going to be again an important stuff, because in this case I'm going to talk about updating your application, not updating your underlying infrastructure. There are 100 ways to update your underlying infrastructure. You have infrastructure as code, and a lot of tools, a lot of cloud providers gives you the way to do all those things. But in this case, what I'm talking about is how do I update them. For example, let's imagine a case I have my application running with version v1 of my production application. Now what happened, I've been parallelly, I started the development of v2, and I'm rolling out v2 into production right now. If you think for a second, now what happens when I roll out new version of v2 into production, so I should not have the disruption of my existing services, because there'll be consumers who will be consuming services. So I don't want them to be disrupted until I reach. I don't want them to have it slowly considerably move from this traffic to that particular one. That usually called as in OpenShift and Kubernetes world, we call them as surge percentage. What I mean by that is, unless I get till 65% of my v2 is up, I don't want the service to be disrupted. I don't want v1 to go out. The moment once 65% of surge percentage of this particular v2 is up, I want to slowly start scaling down v1, so that every request now goes to v2. Again, this is a configurable amount of time, but I'm 65% is by default how much percentage for this load balance to happen, so that we have the kind of distribution between old version and new version. We'll see that during the demo as well, how the primitive load balancing in Kubernetes works. But the point is, I want to do a rolling update. This is what I call as rolling update without disruption of services, because that's super critical in today's businesses, because I don't want the services to be disrupted in any way. All right. And last, we'll talk about rebuild of container images. We'll talk about that more on the elementary course. I'm not going to cover that on today's session, but ideally what I mean, whenever I do a rebuild and push the image into registry, I want to have a way by which my application should be rolled out automatically, new version into production. All right. So I'll take a quick pause here to see if there is any questions around these challenges. I think most of you who are in development and who are in moving applications should have faced all these problems. Just going to watch the chat to see if there is any questions around this. All right. So I assume they keep popping the questions. I'll keep monitoring the chat to see if there's questions on that. That's great. So let's go further. So we are in need of a platform. Okay, Gaurav, I think what I mean by orchestration is that how do I deploy my application? How do I set up application configuration? How do I deploy my application on the right node? There are multiple other things which comes into picture when you actually deploy my application. By orchestration, I mean, so to do all these things, right? Okay, take this application, deploy it in easy to compute, for example, Amazon Compute in Asia, in Singapore, or you deploy that in Mumbai data center, and then you want to deploy that along with a node which is having 16 GB of RAM and for example, and then 4 CPUs. So we have all these considerations in place, and then when we deploy the application, your orchestrator, what I call is a component or a software piece or a platform, that should take care of doing these things automatically. So go find out all these things and do application deployment, roll out, roll up, roll down, scale up, scale down, and then manage your ports, make them sure like your replicas are same. So whatever I listed here is something which is able to do all these things, is called as an orchestrator. All right. I think I made sure, like, if you're not very clear, we'll come back to that question again. Just try to digest that to see if that makes sense to you. All right. Great. So considering the time, let's keep moving. So this is where Kubernetes comes into the picture. We'll see about how these things are addressed in Kubernetes, right? Whatever the DevOps challenges, if you have your pencil and scale app, or you can pause on the screen with the DevOps challenges or take a note of it. in the examples coming up, you'll see how we are going to do these things naturally, and how Kubernetes does these things naturally. All right. But you'll be wondering, there is Kubernetes. I can take Kubernetes and I can deploy Kubernetes and keep running. And why should I need OpenShift? So that question which keeps ponging everybody's mind, saying, okay, Kubernetes is a platform that gives you all these stuff, right? Problems like it takes you that it's an enterprise platform, it deploys everything. But imagine for a second, there are a lot of things that needs to go behind the scenes for to make this platform enterprise ready. Okay. And if you imagine a case, Kubernetes does a release almost every 4 weeks, approximately, talking about approximate number, almost every 4 to 5 weeks, you'll see a new release of Cube happening, though they have an LTS right now. And then everything is done as part of the community, right? So whatever in community is not, so once you get to an enterprise level, so I need to have something like which gives me stability and security first. I don't want to keep changing my platform every month because it's really difficult considering my business scenario. So I want that to have a considerable amount of stability there. And then also, like, if you imagine, like, if I'm somebody like who's not into making software, right, then it's not my ownership to kind of go and maintain a platform like Kubernetes, because you have to invest on resources that needs to go start doing the things as well. Okay. And if you think few other things also, right, if you have a learning curve as such, right, if you're going to have a learning curve and you're going to do learning, then that's also going to have a fair bit of problem, right? Because let's say, imagine if I'm deploying a raw Kubernetes, vanilla Kubernetes platform in multiple different cloud providers, including your private data centers, then each one is going to have each different UI. Okay. So in this moment, what I want to do is, like, I just take a pause because I talked to a lot. So what I'm going to do right now, I'm just going to go and pop a URL on your screen. Okay. So I'm just going to say, go ahead and get onto this thing. So you should see a URL on your screen right now. So which should throw you a screen like that. I'm going to stop my presentation for a second and get onto this URL. So I'm just going to give some time, because the moment it reaches, you should see that URL on your screen. If everybody can hop onto this URL, I'll tell you what I mean right now. Why? One of the primary reasons why we need Kubernetes, open platform like OpenShift, to run your Kubernetes applications. All right. So once you're on the screen, basically what you can do is, like, I just pump in some code, like, I'm just saying hello everyone. Okay. We're going to put this email. Now what happens, I have 3 servers. I'll come back to these 3 servers in a second. So all these things is going to go to all these 3 servers right now. You see that I'm going to go on to GCP. So I allow everybody to kind of go on, put some messages on this. Maybe you just play with this for 5, 10, I mean, maybe a minute or two, just to see. I want to explain something like with respect to why OpenShift is important. Okay, so why platform like OpenShift creates a big value when you're deploying application on Kubernetes. So do hang on to this URL. That's a public URL, so everybody can hang on to this. So and thanks Tanya to getting that thing on there. I think everybody kind of go and click this URL. I think, and then get onto this. I think I see a lot of people hopping onto this. I see Chin. I think test me. Hello everyone. And if you see, all these things are going into GCP right now. Okay. If you are on my application, I'm just going to show you a very simple thing right now. Let me this is the OpenShift console. What I'm showing to you. Let me go here and show you the same one, right? So let me go this here as well, and I'll change to a different project so that I get a cleaner, neater screen for you. So it's going here. You can keep playing on that, so don't worry. So I have enough resources to keep it running. So now if you see this, so this platform is going to running on a GCP right now. So let me show that thing for you. So if you see here, so if you go on, maybe let me scroll it down and make it a little bit bigger. If you see on my screen, so this is running on GCP. Maybe I'll use a rectangle for that so that it's easy for you to observe. I just marked this node as GCP here. And then if you go here, it's going to be the same one. And if you see here, I'm running this on AWS. If you see on my screen, and then if you go on to this one, this is going to be an Azure. Okay, I have 3 different clouds and OpenShift running on all the 3 different clouds. But if you see, when you're on a landing page, this is going to give you a unified developer experience. All right. So if you're going to have on this, so this is going to give you a unified developer experience, irrespective of what platform I work on. My application is going to give me the same stuff, right? So this is going to be the same one here. This is going to be the same one here. Maybe I can scroll this a little bit down. And then it's going to be the same one here as well. So that's the first thing, right? When you talk to deploy the applications on Cube, that's going to be giving you a unified developer experience. So a developer deploying applications on Kubernetes, when he's on OpenShift, all he has to learn is that how do I use my OpenShift web console to go and deploy this. Apart from the stability, scalability, enterprise ready features which we have, so apart from all those things, right, the very basic, very fundamental thing for beginners like you is how easy for me to go deploy my application, Kubernetes application. So that's what the whole platform is, right? Irrespective of whether I'm on Amazon, Azure, or GCP in this case, there could be other private data centers as well. But all you're going to learn is just to go how to deploy OpenShift there, right? Deploy OpenShift, take your application. I have a container image, deploy the Linux container image from there. All right. So you've been playing with this for some time, I see. That's great. I think now we see OpenShift. I see a lot of things, right? Right now, what I'm going to do right now, I'm just going to go to my GCP right now, and then I'm just going to scale this thing down. Okay, I'm just doing it live now. When I'm starting to scale this down, when people start to punch in messages again, now this is not going to go to this thing, right? So this is going to say, now you see this, I kind of gone on to AWS right now. You see people are getting onto AWS right now, right? So this is AWS, this is AWS, this is AWS, and then there was somebody's going to Azure as well. The load is getting distributed, and everybody's right now on AWS, right? And then this has been done dynamically. I did not do any redeployment, I did not do anything, because this is exactly same application which is running on my OpenShift cluster on Azure, OpenShift cluster on AWS, and OpenShift cluster on GCP. All right, I did not change anything right now. And I've used another technology here, so that's called, I'm just going to put the technology up there on the chat for you. So that's going to be the technology called a scupper. I flash it on the screen as well. I'll put that on there. So that's called a scupper, https scupper.io. Now don't worry on this technology, but I just want to code this technology here. So that's the technology which we use behind the scene to kind of do these things, right? To kind of do an automatic failure and load balancing. Okay. And then you're all on AWS right now. I'm going to do the same thing on AWS as well. Let me go to AWS. This is my AWS cluster. I marked it as AWS here. I'm just going to go there, go to the same demo, which I call as hybrid cloud. So this could be even replicated with a local cluster as well. Bring it down again. I'm just going to do dynamically. And now what happens if you start to see you're back, everybody will start to fall on to Azure, right? Everybody is right now on Azure, right? All the requests is right now going to Azure. So it works on a kind of an algorithm that goes to the closest proximity server. That was GCP, which is very close to me because I deployed in Mumbai. All of the two things were right now outside from India, so it can't go to those particular places. Right now, everybody is gone. All the traffic from everybody is going to get onto Azure right now. Everybody is on Azure. So I'm going to put one more thing like hello. I just say hello, Tanya. That's go right. So this goes there, and everybody's going to go on Azure right now. And then I go and take it back again, right? Just go here and then scale it back again. While you do this, I'm going to do this up and running in a second. So this should be up and running in a fraction of a second. And then you should see people falling back to GCP right now. You see this is everything happening on the fly. So this is what I call about this hybrid cloud, right? What I mean by hybrid cloud, you in most of the organizations, you might be having your infrastructure on AWS, you'll be having infrastructure on Azure or any other cloud for that matter, or AWS, Azure, GCP, your private data center. We combine everything together. That's what we call as hybrid cloud. In those kind of scenarios, when I'm using platform like OpenShift for deploy Kubernetes application, then there's no big change for me. The learning curve is very less. The ownership, the total cost ownership, what we call as TCO, is also very less. And the people keep doing this because, and then just deploy OpenShift, and then you get everything what you want, right? Without any big fuss. I'm getting this application and then start running this on there. All right. So I think that's the power of OpenShift. That's the reason why I call us Kubernetes. I mean Red Hat OpenShift as enterprise Kubernetes, because I get all the enterprisey features. Maybe I don't have time to cover everything on today's session, but just imagine that we'll be having a lot of other features like stability, scalability, tested images, and then make sure that your application you're deploying as covered by RBAC security and all of the stuff, right? And I allow you to go and watch this video. this will we'll be getting as part of the slides. So this was our 2015 demo of Red Hat OpenShift. Why I call this is because, for example, like what happened when Google actually open sourced. This is a little story about that. When people open source, Google open sourced Kubernetes 5, 6 years back, they called up us and asked like whether we are interested in collaborating with them in getting this platform up and running. All right. In that case, if you imagine a case, so we said yes, we hopped onto this, and then we re-architected our earlier OpenShift on top of Kubernetes, and then on 2015 keynote demo, Red Hat Summit keynote demo, on the stage we were able to spawn up thousands of containers. You can watch the video right there. Everybody who was sitting as part of the audience on the keynote were able to get one container for them on the fly on the stage. Okay. So you can go watch that. I'll give that thing to you. The link is there. You can just go watch that video, the complete video, to see what's the power. So why I'm saying this is because we have been with Google, we have been with the Kubernetes community since 6, 7 years. That's the trust and that's the amount of investment which we have done on the Kubernetes to make sure that OpenShift platform is so robust and enterprise ready. And also we put in all our enterprise knowledge of doing Linux. We have been pioneering Linux, and then we put everything on that and make sure that the users get a wonderful Kubernetes platform which is gives you unified developer experience, value for money as well. Okay, so that's the reason why I say that whenever you do things, even all the demos I'm going to show in a second, in a few minutes, everything is going, I'm going to run kubectl commands. We'll talk about what is kubectl in a second, but all these commands are going to get run against my OpenShift clusters, what we see right now, right? Either GCP or Amazon or Google. So but end of the day, as I said earlier, I ran the same application across 3 different clouds with OpenShift running on them, giving you the exactly same developer and user experience. All right. So I'll take a pause here again, probably to see if there is any questions before we go further. All right, I think Jyoti, that's a great question. What you asked about. I gave you a few examples of that. Probably like if you can drop me a note offline, I can give you more details about what exactly the difference. I think which I think I give you some links where you can go and read this. As I told you earlier, like the robustness of the platform is what is more important, and the day like what are the amount of total cost ownership, learning curve, unified developer experience, etc., etc. I'm not going to argue about I'm not going to argue about what is there right there. What's a GCP Apple to Apple comparison? But if you can ping me offline, I can get you the details of that as well. Right? And I'm really not sure whether Anthos can run on any platform outside Google as of today. Okay, I don't even know that it can run. But for OpenShift, it can run anywhere, whichever platform, bare metal, virtual machines, cloud providers, everywhere you wish to. I can provide the keynote demo link. Give me a second. I'm just copying the link address from there. I'm just putting on the chat. Uh, there you go. That's great. All right. So what else we have? So yeah, and we are going to see what about Kubernetes, right? So this basic thing, right? So we talked a lot of theory, a lot of history, a lot of story about how Kubernetes evolved, what you've been doing, and all this stuff. So right now, let's talk about a few important things as a beginner, right? When you start to play with Kubernetes, these are the very basic things that get you started, right? Tomorrow, after today's session, when you go back and you want to get started, so these are the terms which you come across. So I'll try to introduce what these terms are and how to play with them, so that you get the very first get started experience, right? On this as well. All right. So if you see this one, what's a pod? As a pod is a very basic element. We'll see about more about pods in a second when I talk about them, show demos. But the term pod is something which can run your container. So that's what pod means in Kubernetes. And this one was derived from your typical pod, what a pod for a whale, where a group of whale lives, right? Anything related to Kubernetes are going to be sea, ship, sailing, and all that other stuff. So this is going to be the same stuff again here as well. If you see pod, the pod is going to be where you run one or more containers that's going to be deployed in a Kubernetes platform. That's what a pod is about. So let's me go. There's one more question along. No, Scupper doesn't come along with OpenShift. So you have just to do a deployment. It's just a very simple deployment of Scupper. You can just go deploy that. It doesn't come along with OpenShift as well. So okay, so Vinod Kumar, that's a good question. I think probably I can answer you offline, not now. I think what people are doing on IBM Cloud, but I usually do this because I have the scripts ready for these platforms. which makes me up and running quickly. Okay, so that's the whole idea. Okay. Um, so coming back to Kubernetes terms, if you see the kube terms here, so I have a pod, I have a replica, I have a service, and a person voice. So these are the very basic elements that we're going to see on Kubernetes here. The pod, as I said earlier, is going to be one or more containers that's going to be run, which is going to be ephemeral containers that's going to run, come up, do your job, and go down. Just like the pod, you can imagine like how do I do a Docker run or a Podman run of my Linux container? The pod is going to do it automatically. A replica and a deployment is basically is going to be a superset of pod, which is going to take care of doing replica and deployment. Basically what they mean is, so as I said earlier, I want to do a scaling, right? I want to do scale from 1 to 10. I want to do 10 replicas of this particular pod. You're going to see that in a demo as well. The whole idea is like I want to have somebody who knows what's the template of the container looks like, so that I can recreate them quickly when I say scale up. That's what replica is going to do. And deployment is going to be a superset of replica, is kind of parent of all these things. Take care of that. I have the necessary labels. I'll come back to the labels in a second again. And then deploy the application so that I have the pod template, I know the replicas, I can attach health checks, resources, as well as set the image as well. All right, that's a deployment. So we'll see about all these three objects during demo. And also service, that's very big. How do I access the container which is running, the service which is running inside the container? That's going to be done by service. It's kind of, it can also group pods and do a load primitive load balancing amongst them. We'll also see that during our demos. How do we do the load balancing as well? And also we also have a data, that's why our PB. We'll not cover PB as part of this beginner session. We'll be seeing more on pods, replica set, service, and labels. Labels is nothing but key pair values associated with each of your deployment or each of your Kubernetes resources, so that you can pick those resources for doing any kind of load balancing or deletion or seeing logs, etc., etc. We'll see about more of them in detail when we actually run the demos, which makes you much clearer as well, right? So basically, what's Node? Node is where your pod gets deployed. So Node, in case, is a physical compute. It could be a virtual machine, or it could be a cloud, or it could be a data center machine, or any kind of thing, right? So master is one thing which takes care of controlling all your nodes. It knows where your nodes are deployed, watches IP address, and all of the stuff. So anybody like your dev or ops with the necessary permission can deploy my application into production, right? For example, as you see on this, I have a kubelet process that runs inside each node that takes care of running your pod or running your Docker containers, end of the day, or Linux containers for that matter. All right. So that's what this looks like. So I have pod, I have this. Okay, there's a question from Rohit. The example is showed is using Kubernetes cluster nodes in GCP, AWS, and Azure, orchestrated by common OpenShift orchestrator. Okay, so no, I think Rohit, I think there's a slight confusion here. So OpenShift is a platform, which is a Kubernetes-based platform. Okay, the underlying core of OpenShift is Kubernetes, but it adds all top of enterprise features on top of that to make it more stable and robust Kubernetes platform. It's exactly same as your SEC or your other Kubernetes platform. There's no big difference, but only thing, as I said earlier, security, safety, and the amount of investment that you have done from engineers who are part of the upstream Kubernetes projects who has gone into those products to make it more enterprise ready, classy Kubernetes platform, right? So there is no orchestrator. Orchestrator says it's still the Kubernetes platform which orchestrates stuff entire, even within Kubernetes, even within OpenShift as well. There's no big difference. So that's the reason I keep calling OpenShift as enterprise Kubernetes, right? That's what I call it, right? So coming back to this, so we have nodes. We have all application deployed on nodes. Um Node is not considered as a pod, Sunil. I think a pod is a thing which runs a container. A node is a compute. A compute, it could be a VM or a physical machine or a machine in the cloud, anywhere. It could be just a compute, which call it node here. A pod is the one which runs your container. For example, I have a Java container which can run inside a pod. Node is where pods are absolutely right, Mohammed. I think nodes is where the pods are scheduled. You're absolutely right. So that's what I'm going to show next. Um, uh, no pods run on nodes. The pods run on there. There's not going to be a pod. Is kind of, you assume that it's like a logical grouping of your containers, right? Runs your containers end of the day using kubelet. Uh, So let's go back. And then what I mean by cluster, it's going to be Kubernetes declarative. Mean to say like I'm going to run, let for example, a Tomcat image with 4 replicas is going to be deployed. That's going to go deploy onto each of these node, right? Your kubelet, each of the node wherever you're going to run. So this is what's going to happen. If you see here, so you have 4 Tomcat instances running here. So as I say here, so this there's one Tomcat here, there's one Tomcat here, and there's one Tomcat here, and there's one Tomcat here, right? We have 4 Tomcats running right now because we said we're going to run a Tomcat image, which is going to be a Linux container image getting deployed as a pod. This whole stuff is called as a pod here. So whatever you see here, this old stuff, what you see here is a pod. So this one pod, this is pod 2, this is pod 3, this is pod 4, which is running each container there, right? These are pods, and then they are running Tomcat images, Linux container images on them that are deployed on your node, right? Are just getting deployed on my node, which is nothing but your physical compute here, right? I have one node here, one node here, one node here. All right. So okay, Sharath, I'm going back to the previous slide. Let me go back there. Let me go here. I need to take this off. My drawing back. All right. So I'm on the previous slide. I think there's going to be 3 masters, which is going to be the very basic minimum if you want to run a HA cluster. I think, but in my example, I'll show in a second that I have a master and a worker together because it's my demo case. But if you have a single master, then you don't run it on HA mode. But OpenShift right now does not allow you to run with a single node as of today because it minimum needs 3 masters because to have the load balancing and HA available there. Uh, uh, I think that goes back, and then let me go here and further. I need to start demo. I think let me take a tab on my time right now. Okay, I have 45 minutes more. I have enough time to do my demos. All right. So let me take a few questions right there. So absolutely right. So you're Gaurav, you're bang on. Pods runs containers. Pods is kind of holds containers, and pods are going to be deployed on the node, and that's going to be managed by node. We'll see that when I run the examples. I think there was a question from Durga asking me, instead of keeping a dedicated master node, can we run the master components distributed across the nodes? Okay, actually, that's what happens. So there's not going to be any dedicated master node. I'll come back to that point again. Durga, when I run my demo, we'll see what's going to happen. It's all going to play with what I call as labels, right? I'll come back to that in a second. All right. I think there is a question for I think, and thanks Anand for popping in to answer the few questions. And I'll come back to the questions again. Keep popping them on. It's really good to see that there's a lot of questions. But let's be cautious of time as well. What happens when a pod fails, right? So we have talked about a lot of DevOps constraints some time back. If you see that right now, when this particular pod fails, as you see on my screen, I'm going to have the pod fail right now. When the pod fails, what happened? The Tomcat node, which is right there, so that's going to get relocated. If you see this Tomcat node right here, this is going to be failed because this whole pod has failed. So what basically happens once the failure is done is that the failure is going to move this Tomcat into new node here, right? You see this, a Tomcat has been relocated and redeployed. That's because there is a replication controller which runs within Kubernetes. That replication controller is going to monitor where my pods, whether my actual pods, I said I need 4 pods, but I have only 3 pods running because my other pod crashed. So now what happens, it automatically go relocates this particular pod or distributes, I should say, a pod across the nodes, worker nodes, which I have. Okay, that's what's going to happen. It's going to go distribute the pods across the worker nodes, right? So that's what is going to happen with this case. So when I'm going to deploy my pod, my Tomcat crashes, and then it's going to get redeployed this. The same thing is going to happen even if a node fails. Automatically have what happened right now. If you imagine in this node, you see that there are 3 pods, one Postgres and one MongoDB and one Wildfly. We have 3 pods here. So these 3 pods are going to be relocated into a new node, right? Let's see there. This pod fails. What basically is going to happen is going to be go here, and then now you see these pods are getting replaced here, right? You see the Mongo coming there, Postgres going somewhere else, and your Tomcat also, and then even your node also comes back. All right. So this is the kind of orchestration which takes care by your APIs and schedulers and controllers. These the scheduler and controller you see on this thing, these are all processes. These are all not nodes. Okay. So these are all processes, API, HCD, scheduler, and controller. These are all processes which runs on a node which is labeled as master. I'll come back to that in a second. Just bear it in mind, just make a note of this. So master is not a separate node. Master will be on a separate node, but it's part of the entire cluster. It's not going to be, for example, in this case, there's going to be 6 nodes here, and one of these or 2 of these or 3 of these could be master nodes. Okay. And whenever it's labeled as master node, then that particular node is going to run all these processes as I listed here. Okay. I'll come back to this again, how all these things work in a second. So let me go back to my presentation and then do a few more things. But I see a lot of questions popped up. Satish, Ansible and Kubernetes are totally different. I don't want to mix those contexts here. So just imagine that Ansible is a tool to deploy stuff, but Kubernetes is a platform on the whole to run stuff. Okay, Ansible will not run anything. Okay. Um, how OpenShift manage a CNI network? I think I'm not a big network expert, but all the network stuff are managed by your OpenShift installer. When you install stuff, we can even configure the network as well. We use software defined networking for doing all of the stuff inside. So as I told earlier, I'm not a big network expert, so I'll try to not go deep into that question. But if you can drop me an exact note or see the OpenShift docs, then that's going to give you more information on that. Pankaj, if you want to go try thing, you can go to, I'm just going to type these couple of URLs, try.openshift.com. I don't know why I'm not getting this. Okay, try.openshift.com. That's going to be the place where you can get your own OpenShift instance running. And then if you want to have a upstream version, that's going to be okd.io. That's going to be the upstream OpenShift distribution. Um, Yes, you can do. If you go to try.openshift.com, you have all the information you need. I'm going to pop that on the chat so that when you come back to the session, you know where to see. Try.openshift.com. I also put the link on the chat. You can go there. And then there's also something called as https okd.io. That's going to be the what I call as the upstream version, the open source version of that as well. And then try.openshift.com needs you to have a compute. You can have an IBM cloud, or there was somebody asking about IBM cloud. You can also spin up that on IBM cloud if you go to try.openshift.com. If you have those credentials, you can get your cluster up and running in a second. All right, I can even have a single node cluster running as possible. Yes, Gaurav, I think the load balancing gets automatically done. You don't need to worry about that. It takes care that there are multiple policies you can create so that my distribution happens across in the common way across all these platforms as well. Um, how does a node differentiate itself as a master? Rituja, I think I'll come back to a question in few minutes. Okay, that's a good question. I'll come back to that in a second. Um, So Gaurav, I think when you go to EKS or Azure services or GKE, then you're logged in with the features of Kubernetes given by them. They give you raw Kubernetes platform, as I said earlier. If there is a bug with that particular version of Kubernetes, then it's going to take time for you to fix. They're not going to fix it only for you, right? But imagine a case when you go for a hybrid cloud scenario, you're going to distribute the application. Your data center is not just going to run on Amazon, it's going to run on Amazon, GCP, Azure, Alibaba, or something else, right? Even a private data center. I want everything to be having a common unified interface. Okay, that's the reason where the benefit of OpenShift comes in. Um, Amol, I think different between Docker is the one which runs your container. The Linux container is what is Docker. It's a runtime basically. OpenShift is an orchestrator which can run multiple different Docker containers on that. Um, Replication, I think I can hold on to few questions. Probably I'll run the demos, so all your questions that you're asking right now will be answered on the replicas. Obviously that will be answered on the master node. That will also be answered. Port conflict, yes, we'll be seeing that as well on the demos. Uh, the master nodes can be one, and minimum is three. Three is more than enough to have master nodes, because master nodes are typically not schedulable by default, which means that I cannot deploy my containers. So I'm going to get back to all these questions again. Maybe I'll reserve some 5-10 minutes at the end of the session to go back to questions again to see, because I just want to throw you demos, so which can help you to understand few things which I was talking right now. All right. So one of the things, the very common question which came across is like, how do I know a node is a master or a thing, right? That's exactly done by labels. Okay, if you imagine, labels plays a super crucial role in any of the Kubernetes objects, whether it's going to be a pod, it's going to be a node, it's going to be a your deployment or a service. We'll apply them more soon in the coming upcoming sessions, but you'll see them that these are going to play a very big role in your thing, right? You have, for example, I shown you labels here. So for example, this particular app is going to be an environment is going to be labeled as dev, and there's going to be app cool and version v1, right? And then there's going to be another node where they're going to be app cool again, environment dev version v2. Okay, and that's going to be like this. We can label all these things using labels. Labels are nothing but key pair values. Every object, including your node, which is a compute, is going to be a label, right? And that's going to answer your question outset. People were asking about how does a node become a master. A node is considered a master once it's labeled as a particular label, right? We'll come back to what label is that in a second when I show the demos. Okay, but imagine that when you label is going to make a super important stuff when you're going to run these stuff as well. All right. So this again few examples of that. Let me stop here and go back to the questions, and then I'll come back to these resources later. So let's go back to demo. So all the things which I'm going to run on this demo are all available as part of the Kubernetes tutorial. So you can go to the tutorial from here. I'm just going to flash the tutorial URL on the chat. I just pass this and just going to paste this also here. https dn.dev/ cube tutorial. Okay, so this also shows you how to get started a Kubernetes, a very primitive Kubernetes container, a single node kube container on your laptops if you have enough power to start trying these tutorials as well. And this is where the GitHub repository, if you see any issues when you're trying these things, you can pop the questions there. We'll be happy to answer your questions. So Red Hat developer demos Kubernetes tutorial. The dn.dev URL, the bit.ly link which I pasted on the chat, that's going to take you there as well. And all the commands that I'm going to type right now as part of the demos are all part of this tutorial. So in case if you miss the commands, please don't worry. So everything is there. You can go try out all the commands right back, right? I'll not be tying step by step as I shown here. I'll be jumping sections, but for that matter, but I'll be following the sequence of things so that it makes clear for you, right? So what all things which we need to understand here. All right, so these are the tools. You can go there, cube tutorial, and then you have installed this particular stuff right there. You can also have the try.openshift.com to get your own cluster. But in this case, as I told earlier, I had 3 clusters right now, which is going to be this Kubernetes one on AWS and OpenShift on Azure, and I have OpenShift on AWS and Azure at GCP as well. All right, so 3 clusters for me right now. And then let's go back to see the very first thing which you want to see, which is your very basic element, right? So now the first question comes to you is that how do I interact with the cluster? That's the very first thing that we're going to see right now. The tool which is going to do this is called kubectl. Okay, kubectl we call as kubectl, but technically we call this, colloquially we call them as kubectl. And then this is a tool which is going to use to interact with this. If you go to the tutorial link which I pasted on the chat, that has the link how to download and install and configure kubectl on your local machine. All right, so you have kubectl here. So and then as good as any tool, just going to say help. That's going to give you all help commands that is going to there. We're not going to see about that. Let me clear the screen now. So now the very first thing I'm going to see right now is that using kubectl, the very basic element of your cluster is your nodes. So how do I get nodes? Kubectl get nodes. Okay, this is going to give you all the nodes that is part of this particular cluster. But now your first question comes here. Even before you go there, how does your kubectl knows to go to this particular cluster? Either it's going to be, as I told earlier, We have a GCP, Amazon, and Azure clusters, or OpenShift, or Kubernetes for that matter. But how does this know have to go here? Okay, that's determined by what is called as kubeconfig. Okay, I'm just going to say kubeconfig. So now I said put as kubeconfig here. This particular kubeconfig is going to take care that, okay, this is going to be, I just named it as like what you see on my screen, GCP, so that I know which kubeconfig is that. Kubeconfig is the kind of an environment variable which has an information about your login and your credentials, your certificates, etc., to kind of get an access to the cluster. The moment you install OpenShift or even Kubernetes for that matter, so it will give you automatically a kubeconfig file that is going to have all this stuff. How do I know what's there? Kubectl uh, config, and then I say dash dash view. I say sorry. If you see this, this has given me the kubectl for this matter. I'm going to have a cluster here. It says my cluster authorities data is omitted because I'm going to have this cluster right here. Um, and then it's going to say this is going to be GCP server which is going to run there. Okay, I'm just going to go here onto my OpenShift, I mean Amazon cluster. I'm going to do the same stuff here. Echo kubeconfig. Okay, I'm going to go to sys config or just say kubectl config. Say less. Okay, now you see this a cluster is AWS cluster, and then I'm going to have my API server through which I'm going to interact, and then my other certificate and other details are redacted again, right? And it's going to be same thing again. Just echo kubeconfig, that's going to be giving you the kubeconfig file for now for you. This is going to be there, like, which you can use to kind of interact with this thing, right? So this is a very basic element. How do I interact with my kube cluster, which is OpenShift in this case? Have to get an access to the kubeconfig, which is usually done when you do a login to the cluster, or when you install. Your admins will have the kubeconfig, will give you the credentials to log in, so you can just log into the cluster. All right. So that's what we're going to do here. I think we had the same thing with Azure as well. So it's going to say Azure cluster. I'm going to go here and then do the same stuff. Kubectl, just do echo config u, kubeconfig. All right, that's going to echo the config here. So it's going to say kubeconfig here on Azure cluster, and then we can just say kubectl config view. Yes. Okay. Going to say the same thing, an admin, and then I have a token to log in, etc., etc. And then that token is kind of expiry token. It keeps expiring, and then you're going to log in here, and then it's going to be an Azure cluster. Okay. So how to interact your cluster? First, second, you need a tool like kubectl, and then you need to interact with the thing using a kubeconfig file, which you usually get once you install your kube cluster, or when you do a login, you get a kubeconfig file automatically created by your tools. So that's the way you access this particular cluster for that. All right. So once I have kubeconfig in place, I have logged into my cluster. And in this case, I'm an administrator right now, so that I can show you all the stuff that is required. But again, these are all controlled by RBAC. I'm not going to cover much about RBAC on today's session. So let's say, how do I get my nodes? Right, I'm on a GCP right now. I say, okay, these are the nodes that is right there on the thing, right? For example, I have a node, and then you will see this one. Let me go here and then mark this on for you. You see this one. This is okay. Okay, I'll change my tool so that I can draw pretty neatly here. These are all workers, right? This is all the. I just have a 3-node cluster for the demonstration. But in this case, if you see, both the node is having a kind of a purpose as a master as well as a worker. It's a role basically. How do I identify the role? So that's what I'm going to show you next. When I do get nodes, there is an option to show labels. Okay, we saw about labels, right, some time back. We saw about that in Kubernetes terms. If you're not, if you go back and see labels, these plays a super important role for this particular stuff. When I say get nodes and show labels, it's going to be a big thing which is coming up. But what I want to show you here is these two things. When I mark any node with this particular label, node role, labels are nothing but key pair values. When I do this, then that's going to be make that particular role as master. If the role is going to be master, then by default, nothing gets scheduled or deployed other than the core Kubernetes platform stuff on that node. What I mean by that is you're not going to have application workloads running there. Okay. And then if I'm going to mark or label a node as a worker, then that node is going to have the application workloads running for them. Okay, so that's what we had in this case. We have a master, we have all the three ones as master, all the three ones a worker here, and the same one here also as the master and as a worker here. All right, so that's the thing which makes a difference right here, because each node is a master also, and each node is a worker also, right? So I'm just going to have a master and also I'm going to have a worker here. All right, so node will not run anywhere, Anwar. I think a node is nothing but a physical compute, but to give the role it takes, it differs, right? That could be a master or a worker node. Worker is where your application load runs, and master is where your cube platform or OpenShift core platform stuff runs there. You can still have, you can override that, Amit. That's what I've done in this case, but that's a little bit advanced stuff. Usually it's not advisable to run application workloads on master, because the master has to be quick performant, and then something goes wrong, then your entire stuff goes out. Okay, your entire cluster is destroyed. So how about we get started? I think if you go to the GitHub link, if you follow the tutorial, Rituja, I think it has all the details for you to get started. Starting from scratch, it's kind of do-it-yourself kind of stuff. That's what I'm trying to show you a demo as part of this, but you can also do it yourself as well on that, right? So I mean, coming back to Amit's question, they have only core platformy infrastructure pieces deployed on the masters. You will not have application workloads running on master. It's not advisable as well. But since it's a demo case, I'm just running this case, but it's not done. Does every cluster need a separate master? Yes, obviously each cluster as of today, there is no federation available. So each OpenShift cluster should have its own one or more master. Usually three is more than enough. The three masters to give you an HA, as well as to cover even up to 150, 200 nodes as well, 200 worker nodes as well. All right. So let's get back to this. I think there's no federation. I think I answered Anwar's question back. So let's go and see how do I deploy my application, right? So if you see this is what we have done here. Just go back to help Rituja again here. I'm just following the, if you see this, Rituja, just going back to the tutorial. You see I did the kube config view earlier, and then I showed you nodes and labels, these two things which you saw. And we're going to see about namespaces. Um, Yes, you need to download the code. It's not a very heavy code, just set of YAMLs so that you can play around with that. Okay, you don't need to download the images, container images, because they're already pre-built. You just need to apply. I'll be showing an example of that as well. Yes, Gaurav, I think I have overridden this case. In this case, meaning to say, like, I made, since considering the cost that I can spend on this, I just made sure that each of these nodes become master as well as node, and I overridden the flag to make it schedulable. I can do that, okay, but it's not recommended, but I can make it schedulable so that the application workloads also runs on master. Okay, so those are advanced topics. I'm not going to talk more on that. It's good that you asked the question, but it's doable. I can override that, but that has to be done during installation. All right, so let's go and see what are namespaces, right? So namespaces are nothing but, if you see on my, let me go to the OpenShift console to show you that. So I'm going to go to the administrator perspective here. In OpenShift, we call the namespaces as projects, right? So basically, the whole idea, again, this again differentiates the Kubernetes namespaces from objects. What's a namespace? Is namespace exactly like what you see in an XML or anywhere, right? It's a place where I can go deploy an application, because I can have the same name across multiple applications. So in order to avoid ambiguity, I'm going to deploy the application within namespace, and then I can control your access to the namespace, right? Depending upon the role. All right. So that's what I'm going to do here. I'm going to go here and then say, okay, it's going to be default. I have bunch of, you see, I have around 60 projects here, which are all namespaces again. So I can go deploy. For example, we saw the hybrid cloud demo, the demonstration which I did earlier. We saw this is going to be hybrid cloud namespace, and I have a bunch of pods running here. All right, that's what I'm going to do here, right? And then I can have another namespace which could have the same hybrid cloud backend running, but it could have a different name as well, right? So in order to avoid name conflict, I'm going to go this namespaces concept there, and then start running stuff as well. Okay. Um, so you don't need to Pinak, I think you don't need to worry about how do I install these processes, etc., etc. The OpenShift installer or the Cube installer will take care of doing all the stuff. Your job as application developer is to just to deploy the application into production or whatever environment you are in, right? Sorry. So that's what is namespace. So how do I get the namespace back? Let's go back to the tutorial and see we have a namespace. I can get all the namespaces within my thing. So that's going to give me a big list. Let me go here and then to kubectl get namespaces. That's going to go give me all the namespaces here. It's going to be a lot. So you'll see if I put a WCL, it's going to be kind of 61 namespaces, right? I have all 61 namespaces. I can also create a namespace. That's what I'm going to do next. And then each namespace also has labels. I think I can just show, but ideally it does not have any big labels. But as I said, namespace is also an OpenShift, I mean Kubernetes resource. Every Kubernetes resource can have labels. That's a metadata that gets in. All right. So that's what I said. Each namespace also having label. You see this. This is going to have a namespace. This is going to have a label. There's a lot of labels here. So you can also have a labels attached to your namespaces as well. All right. So let's get a deploy application first. I think we have saw enough on namespace. So what I'm going to do is like, how do I create a namespace? That's what I'm going to do right now. Kubectl create namespace. I'm going to call it as my stuff. That's going to be the namespace that I'm going to create. So I created the namespace. So now what happens? We have to shift into that namespace to start deploying the applications, because otherwise, by default, there is a namespace called as default in Kubernetes where all of the application gets deployed. Okay. So in order to avoid that, I have to change the context here. That's what I'm going to do here. I'm just going to copy this command again and then put it here. Kubectl config. You know the config command. We saw the config command earlier. And then the current context. Right now I'm on OpenShift on GCP. Change to namespace called as my staff, so that any application that I deploy is going to be on namespace my staff. You see this here. So for the OCP admin, who's I'm logged in as administrator, the context has been changed to my stuff. All right. That's what I'm going to do right now. And then now I'm going to go and deploy a simple application. It's a Java Hello World application that's going to deploy. I'm going to create a deployment called as my app and use this Linux container image. Quay.io is an external registry like a Docker hub where you can have your application built using Docker files and push there. Right. I'm not so we'll talk about more about Quay and registries in the elementary part, but right now imagine that this is just going to be an image, Linux container image is going to be running inside a pod. Right now I'm creating a deployment. The deployment is going to create a replica set, and then replica set is going to create a pod. We'll see all those objects in a second. But imagine that this is what we're going to do right now. I'm going to create this deployment. All right. And then in the lower, I'm just going to say watch kubectl gets pods and services. Now you see this, there's a pod, there's a container getting created. While the container is created, I'm going to look at through the questions as well. Okay, Shiva, I think you cannot have masters spanning across the cluster. There are ways to do this, but that's too advanced topic for now. But you can have masters controlling, but it's really difficult in that case because it has to understand the underlying cloud technologies. Okay, so but you can have something called as a stretch cluster. I can have a common masters for multiple thing, which can control nodes on multiple clusters. That's possible, but it's a super high concept. I don't want to talk that on that, Shiva. I think hybrid cloud, Durga. I think I'll come back to hybrid cloud thing a bit later because I want to cover a few demos to show how applications working, so that you can just at least go back and start doing something on these applications as well. All right. Um, kubectl is open source. Yes. The infrastructure, Nitin. I think I pasted the try.openshift.com. So that's the place where you can go and try OpenShift. I'm just putting that on the flashing it on this thing as well. It's HTTPS try.openshift.com. That's where you can go spin up your own cluster and start practicing whatever you said here. If you want to do it on a laptop, you can go to the tutorial link which I pasted earlier. The tutorial has something called as Minikube, which you can have one local Kubernetes cluster to practice things with. Okay, so we have created this. So let's see what other objects we have. So we created a pod running. So I'm going to say I'm just going to stop this one. I say let me make this a little bit bigger. Kubectl get pods. Okay, I call this deployment since this has created deployment right now. So we have one deployment created, what we call as my app. I'm going to come back to the labels again. I'm going to explain the labels here again. So don't worry about that, NG. Uh, so my app, so I've just created app called as my app. Now the app is going to create also what is called as replica sets. The earlier command where we create a deployment will create a replica set as well. You'll see there is a replica set, and then the replica set is going to create a pods for you, bunch of pods for you. All right. In this case, there's going to be one pod. If you see this here, so there is a pod app called as my app. The my app creates a replica set called as my app with a unique ID here. You see this unique ID here, and then this my app is going to create a replica set called as this, and then it's going to create another bunch of pods, one or more pods. Okay, because my desired and actual count is only one, which is specified in my deployment. When I create, by default it's only one. I can change that. That always going to have the replica set is going to create a ready of one pod got created. All right. So how does this knows how what pod to create, right? That's going to be, but I think that's again the label where it comes back. Okay. So let me do one thing. Kubectl edit deployment. Let me open my code so that like it's right there. So this is my window. What I'm going to do, right? I'm going to show you what's a deployment YAML looks like, right? Because you're not done any YAML for now, but I'm just going to show you what does it know. Again, the significance of label as well. Okay. So, oh my gosh. So this is going to open up in another window here. Okay. See this one. So let me go here. So there's going to be an app, my app, which is going to be a label which gets automatically added. And now the same label gets into my template as well. All right. And then the same label, what basically means by this is that, so you'll be wondering that whenever I change the replica, automatically a new pod gets created. So how does this happen? Is because it goes by labels. It goes and finds out this particular deployment is identifies this template by something called as label, called as my app. And when that goes to my app here on the template, that's going to create you this particular spec. The spec says what's the image I need to run, a few other things, right? We'll not worry about that. Just imagine that this is what is going to be started. If we imagine, if you saw a couple of minutes back, we ran this on a command line, right? Starting this particular Linux container. So a deployment basically it goes and selects, attaches a label to its particular child objects, and that particular one of the child object is going to be your replicas, and then that's going to be identified by the labels, and then that replica is going to create a pod which are all identified this particular label. I think NG, coming back to your question, this is the significance of labels. Labels are nothing but key pair values, and every resource within Kubernetes are attached to the labels, and labels plays a super significant role whenever something is happened. Okay, so let's play a little bit here. So what I'm going to do is, like the replicas I said one, instead of one I'm going to go and change this to two. All right, when I change to two, what basically happens is, like, so kubectl get pods. I'll see one more pod coming up right now getting created, and now you'll see that I already downloaded the image. Why it is taking some time is, right, because it's going to go into a different cluster right now. The node is going to get distributed across the cluster, or it can also control that, but in this case it's going to go out to other containers. Okay, right now I have two pods, and then when you go back to our old commands, you get the replica sets. Now the replica chase is changed to two from one because we changed to two replicas, and then you'll have two pods right now running. Kubectl get pods. I have two pods running right now, and then if you say and then how does, if you say dash dash show labels, you see this pod is having these two labels, right? My app here, and then the other one is generated by Kubernetes by default. So that's how the new pod gets generated, and then your pod is there and the pod is running right now. All right. So let me go and see what else we need to do. Now we have the pod running, we have the deployment running, but how do I access the deployment, right? Because by default, nothing is accessible outside world, right? So I need to create a service basically to go interact with the pod. That's what I'm going to do right now. So let me go grab the command just to save some time of typing. I'm going to go to my thing. So we just watch the events. You can just go watch the events as well. We saw replica sets deployments as well. I'll come back to the logs in a second. I go create a service, right? So how do I create a service? I got a deployment done. I need to go get a service created, expose a service. So I'm just going to say expose a service with load balancer. So basically what's going to happen is, like, let me go and watch this one. I'm going to start a watch. I'm going to watching pods and a service right now. And then there's going to be a deployment my app, and then I'm going to start with a load balancer, and then you should see a service getting created, and then you see this pending, right? Because by default there is an internal cluster IP and portal IP that is available within Kubernetes that goes inside. Now what happens, I wanted to access a service from outside world, so I'm just trying to get a load balancer IP. This is going to go to an underlying Kubernetes stuff. That's where it's going to go and create this IP address for you, right? It's going to go to your Kubernetes, and then Kubernetes is going to use your underlying infrastructure, AWS or GCP or Azure or your bare metal, and then create an IP address for that. It takes a bit of long time for that. Okay, I got the IP address right now. So this one. So I'm just going to do a curl IP address. I think I should be running there, right? I think I should give 8080 there. I'm not given the port 8080 there, so I just say 8080. See, I got this output from the pod, which says a supersonic subatomic Java Quarkus. It's a Quarkus application, but I'm going to be able to go and access the application from the outside world by exposing the service, right? When I say kubectl get svc, that's going to show you this particular service, which is right now available for you. All right. Um, So I think there are multiple ways in this section. I'm not showing you YAML crafting, but YAML crafting becomes essential for you to write all those stuff. That's part of the tutorial. And you go to the tutorial, it gives you details about how to create those YAMLs. I'm not covering that part as part of this particular stuff. Okay. So I'll come back to the questions again because I want to show you a few more stuff. So we saw that we are able to do this load balancing. I think watch kubectl. I'm not going to go start this watch again. Kubectl get pods. So now I'm going to go to loop it, right? Just watch for these two things, right? CC89Z and then QHKZL. So what I'm going to do right now is that curl localhost. I'm just going to say while. I'm going to do a curl, and then I'm going to. I'm sorry. And then I'm going to say sleep for 3 seconds. It's going to loop, and then I'm going to say end. Okay. Sorry. While just need the IP address for the curl, right? Just have this handy. I just say while. Hey, come on. While again for true curl. I just need to go see the IP address again uh, for this, and then curl 8080 colon 8080 slash, and then I say sleep for 3 seconds, and then end. Okay. So now this is going to, so if you see this, there's an automatic load balancing happening right now, right? So it's between, there are two ports, CC89Z, KHZL, just learning the last name of that. And then you see this, the Kubernetes by default does an automatic load balancing between these two things, these two instances of the thing, right? Though they are running on same port, same thing, I'm not worried about how to configure my port and all, because they're running inside the container, and kubectl Kubernetes platform takes care of avoiding these port conflicts automatically, right? So that's a primitive load balance that we have. We can also do some sophisticated load balancing, but I'm not going to talk about that right now. So what we saw right now is that we're able to deploy the application, see deployments, scale up the application replicas, and also see the stuff, right? And again, and that is what is the big difference again, the vanilla Kubernetes platform OpenShift, right? If you see some time back, I did a manual exposure service, right? If you see this command which I did earlier, I did a manual expose of the service using kubectl expose command, like what I show here. But what I can also do is, like, when I go to my kube platform, and then I go to the project which has this one, that's going to be my stuff. And then I go to networking, and then there's something called as routes. There's a default HA proxy ingress which is deployed within particular OpenShift platform. So that can expose your route to the outside world using the same domain name. Okay, I'm just going to say create route. I call this as hello world. Okay, and then don't worry about host name. I'm going to give the path. I'm going to select a service, my app. It's going to ask you which port. I want to do an 8080 port. If you want to make it secured or not, I'm just going to say secured in this case, and then allow edge termination and allow the traffic. Okay, these are all done through the console. And now the moment I click create, this is going to create a route for me, and then going to give me a public URL with my domain, because when you deploy an application, you'll have the domain name as well. And when I click on this, this is going to give me the same stuff which you saw on the command line, right? But in this case, I've not used expose. I use a domain name, but I'm exposing using my ingress, which is already there in HA proxy ingress, which is deployed inside OpenShift. With that, I can quickly create a route and expose to the outside world. All right. There are a bunch of questions. I'm going to pause for the questions until I finish my demo, and I'll come back and answer the questions as well. We can deploy multiple node pod at one go. Absolutely, Prashant. That you can do that with ease. No big deal at all on that. Um, if the labels are same, are they differentiated based on any ID or key? Labels are always key pair values, so you cannot have duplicate labels. The label has to be unique. Even if you write your YAML will not allow you to have duplicate keys. All right. So coming back to this, so we saw about exposing a service and all of that stuff, and then we saw about pods, replica sets, and again you can just go. This one gives you more detail, creating each of these ones individually. You can go and see them again to see how we can create them individually as well as part of the tutorial. I'm not going to cover that for now. We saw about service, and then we saw about service, how service is going to able to expose a service and get this thing one. And a very important stuff which I want to talk about service is the selector, right? I'll come back to that in a second. So let's go here, and then I'm going to have two windows open. Kubectl, get pods, show labels. All right. So now you'll be wondering like how when I created the service, how the service was to go pick these pods up. Okay. So now let's do this. So let's do the same curl command. I'll just do a different deployment for the fun, right? This is done using selector, right? I'm going to show you how the actual selector is going to work. All right. So you can also watch the logs. Kubectl logs. Nl stands for selector. I can use a label selector here. App equal to my app. Sorry, my command was wrong. It's going to be kubectl. It's going to see the logs. If you see this is going to get the pod logs. The container running inside the pod is going to stream everything into std out, and that's what is going to be deployed. So it's going to get the logs for all the containers that have this particular label. Okay, I can also go and see that for an individual pod. Kubectl get pods. Let me have that pod names. I have two pods here. I can also go get the this particular stuff for this pod as well. So that's going to be my app. It's going to say kubectl logs. It's going to give you the logs from the specific pod, right? If you know the pod name. In the earlier command, I used a generic thing going using a label. But in this case, what I did is like I went ahead and picked the particular pod and then saw the logs as well. If you're on the tutorial, we talked about another tool called a Stern, which can go do a regex pattern kind of stuff and get the logs from all of the stuff. All right. So let's go back to another interesting stuff before we kind of sign off. I think we have 3 minutes. I might need to go a little bit overboard because there were a lot of questions which you have to answer. So I lost a bit of time. So this is the one last thing which I'm going to show you. So we'll create a new, I'm just going to copy these commands. As I said earlier, I'm just going to create a namespace and getting onto this namespace again. All right. And now what I'm going to do is the very first thing, I'm going to create a pod, right? Let me go and copy my command here. So I'm just going to create 3 services, in fact 4, and I'll use the same technique as we did earlier, right? So going to create a node deployment, and then I'll come back once I trigger a deployment. I'll come back to show you what I mean by this. Okay, I'm going to create a deployment here. Okay, I have a Go deployment created, and now I'm going to create node 1. Okay, I'll go to my CLI. So these are done using YAMLs. So I'm not using the commands here. I'm just going to be using doc and YAMLs, and I also want a Python one also, right? So I'm just going to create a Python one. All right. And now, so you'll be wondering like how the service picks up, right? The labels, the significance of labels again. An ingress is basically a way to get inside the cluster. So how do I get inside the cluster? Is called as ingress. The traffic getting inside the cluster, right? So now I'm going to create a service, okay? And if you see the service, I want to take a moment to explain the service here. So I'm just saying call as my service, and then that's going to be having a label called as my stuff. And then what I'm trying to do is that the selector here, right, is going to say that which pods needs to be selected. Okay. That's where it goes and selects all the pods and does a load balancing between the pods. That's how Kubernetes works. That's the internal mechanism of Kubernetes. That's what is done here. So I'm just going to go create this one right here. And then I say OC expose. I can also do OC is a OpenShift client to do the exposure. I'm just using the OpenShift client to expose. OpenShift client and kubectl are pretty much same, except that you can have more freeness when working with OpenShift specific objects with OC. Okay, I'm just going to say OC expose service, my service. What I'm going to do, and then I say OC get routes. This is going to give you the same thing. Whatever I did using the console, I'm just showing you from the command line. Now, when I say this one, right, this is going to fail for me right now. Okay, when I say while true, I say curl curl and then sleep dot 3 seconds and then end. Now this is not going to work for me because if you saw earlier, let me go to the browser to show you on my service. I said the selector is going to be in service pods, right? But if you imagine the deployments which we did, this node deployment, the label does not have in service pods. The same with the Go as well, the same with your Python as well. So which means that I have 3 pods right now to be load balanced, but my service will not go to these 3 pods because the label selectors will fail. Basically, it's like a SQL query, select star from this particular thing where x equal to y, right? Something like that. All right. So that's what it's trying to do, but none of the things work. But how do I get them back? It's pretty simple. I go and start to label stuff, right? I just go to my Python app and then say label the pod which has label called as Python with in-service pods, right? Because that's going to be my selector. That's going to do this, and then you start to see this Python service comes into picture right now. All right. And the same thing I'm going to do, I'm going to go to my node and then going to do the same stuff. Now what happens is one more pod comes into this. The node is going to also come into the load balancing picture. All right. And the last one we're going to do is using Golang and do the same labeling Golang to get into in-service pod, which is going to be my service selector. And there you go. The node also comes into this. In this way, if you see this, your labels is super crucial. NGM coming, I reiterating back to your questions because label is how the entire stuff works within Kubernetes. Your load balancing, your service selection, your deployment selection, your replicas, etc., etc. All right. So I think I did enough of this on that. I think if you go back to this thing, all these things, whatever I explained right now is as part of the beginners thing on the tutorial. You can install your mini cube cluster locally and start testing this out to get more information about this. If you have any questions, please do drop me a note or ping me on my Twitter DM. I'll be happy to answer the question. Or you can also ask your questions by opening an issue on this tutorial thing. So you will either me or somebody else will be answering your question as well. But it's please do ask questions because I know this is your first session. There will be a lot of things which you talked about, and I'm absolutely sure there will be a lot of questions also because I'm seeing a flow of questions on the chat. I'm trying to answer each of them, but I might miss few things, but I'll definitely answer you when you go back and log an issue with the question on the tutorial. We'll be happy to answer the question or drop me an email or send me a DM on Twitter. I'll be happy to answer the question as well. So with that, I'm going to watch a few more questions on the chat before we close the session because we are on the top of the hour, just 3 minutes over. Uh, Prashant, I think the tutorial link is https dn.dev slash cube tutorial. That's a tutorial. I think I'm sorry, I made a mistake on my chat. I guess. How do I take this out? I think there's a typo there. It should be cube tutorial dn slash cube dash tutorial. So that's the tutorial link. Okay. So there are a bunch of questions. Can we use Docker command with kubectl? No, you cannot use Docker command with kubectl because Docker is just a runtime. Everything has to be controlled using kubectl. Um the monitoring tool are always there. Arnab, I think OpenShift, that's again an enterprise feature that we have added on top of OpenShift. So OpenShift has Prometheus and other alerting driven Grafana dashboards. Everything is there. Probably let me see if I can quickly show you some stuff. Um Arnab, to answer your question, I can go to the developer perspective or administrative perspective wherever you want. I have the monitoring here, so where I can watch my monitors as well, right? Your microservices could be monitored here as well. And there is also an exclusive Grafana dashboard. You can go here. I'm going to show that also for you. Go to the administrative perspective in OpenShift. Go to monitoring. You have the dashboards here. So where I can also see the dashboards here, right? And I can also pull out the Grafana UI to see the Grafana dashboard as well. So this is also, again, these are all packed as part of the platform. Sometimes we can why you use over because all these don't really need it. The whole idea is okay. Um, just going to go down to see questions. I think that's pretty much. There is no more question. You can keep popping it, dropping me back the questions as well. I'll be happy to answer questions. I know there is a lot of stuff which we covered today. So all the things are there on tutorial. Even if you miss my commands, you can come back to the tutorial and watch the commands again because I want to spend time more on the basics and the theory. That's the reason why there's a bit of balance here. And if you have any questions, again, as I said earlier, drop me an email. Happy to answer the questions. But I would suggest that you open an issue on the repository because in that way, like if not me, like somebody else will keep answering your questions. Okay. I think I'm top of the hour. I should say goodbye to you all and thank you for part of this particular session. And please do come back to the session we are going to have on August 26th. If I'm not wrong, probably you'll get an email communication on that, where we'll be continuing from where we left off, and then we can also take a brush up of these topics as well during that session, and then continue with the elementary of how to build image and other stuff that we do. We'll be seeing more on services, load balancing, and all of the stuff during that session. It was fantastic meeting you all, and thanks for your patience. Thanks for popping in. It's great, and wherever you are, stay safe and healthy. See you next time on another master course session. Thank you. Goodbye.